All right, it's recording. Exercise 4H. This is the last exercise of chapter 4. We are now going to be solving literal equations. You'll find a lot of it will rely on your chapter 4 material, which is your quadratics and cubics. Okay, let's have a look at the first one. So this is from your textbook, question 1b and 1d. First one, you've got x cubed minus 7ax squared plus 12a squared x equals 0. It says solve for the literal equation. What they mean is find x. To solve for x, when I see an equation where there's x, x, and an x, first thing I do is I factorize it. I'm trying to make it simpler. So let's factorize it first, and then you tell me what you're going to do next. So here we go. X bracket x squared minus 7ax plus 12a squared is equal to 0. What would you do next? Hands up if you have an idea. What would you do next to solve this problem? We're trying to solve for x. So I can already see x could equal to 0. What would you do next?
I would factorize that like a quadratic, because I can see 12, negative 7, so it would be negative 3 and negative 4.
Very good. The only little trick here is because they added on the extra a, it just means that when you're breaking out these factors, it's not just the 3 and the 4 anymore, but it's likely 3a and 4a. There's the only way for you to get 3a times 4a to get you 12a squared. So when you factorize it, it should now then be x bracket 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 equals 0, x, and yes, you're right, you've got a 4a and you've got a 3a. The only way to get a negative 7, minus. So that tells me that x must then equal to, using null factor law, it's either 0, positive 3a, or positive 4a. Pretty nice and easy. Okay, so we're just solving for let that equal to 0, let this equal to 0, and solve for this when it equals to 0. Null factor law. What about D? So with B, we were able to see a way to factorize it. What about x squared minus kx plus k now? So factors of k is 1 and k, which we don't know what k is. Is it possible to get 1 and k to get negative k? No. At least we don't know what it could be. So what do we do when we can't do a cross method or whatever method that you use to factorize? What's the next way to solve for x? What's another technique we know? Quadratic formula. So here, we should then be using quadratic formula, quad formula. That tells us x is equal to, and again, a is 1, b is negative k, and c is positive k. So when you put it all together, you should have negative of negative k plus minus root of b squared. So that's pretty much k squared minus 4 times 1 times k all over 2 times 1. That gives me k plus or minus root of k squared. Whoops. K squared minus 4k all over 2. Now, I know this question may not have asked it, but I can see this being sort of an added on question. There's a restriction to this. Especially if I'm trying to find a solution, meaning I can get one solution or two solutions, otherwise there's a possibility I won't get any solutions at all. What's the restriction? So the next question could be, if they would have added on, they'll say, what's the restrictions of k? Okay, so let's work that out. K squared minus 4k, because remember that's the discriminant. This determines whether you're going to get any solutions or not, right? So if you can square root the value. We need it to be greater than or equal to 0. Now, this is where you can refer back to your chapter 4 stuff again. K squared minus 4k. We needed that greater than 0, so sketch that graph is usually what I tell my year 11s, and I'm going to assume for the same thing for you guys. You got your k values versus your discriminant, because remember this represents discriminant now. To sketch k minus 4k, I'll just factorize that, take out k minus 4. So I'm saying I want this graph, k times k minus 4, to be greater than or equal to 0. If I were to sketch that, that clearly tells me k is 0, or k could be 4. Those are my axis intercepts. So 0, 4. Here's my graph. Now we can see our discriminant graph. We said we want the discriminant to be greater than or equal to 0. So that means these are the two regions I want. That part of the graph and this part of the graph. So what's my restrictions on K?
Less than or equal to 0 or greater than or equal to 4.
Very good. Okay, so if they did ask that extra question, that is one to note, that you have to make sure in your quadratic formula there is a restriction because of the square root. Very good. For the next question, if you haven't wrote it down, please add in the x to the power of 4. I missed out on that. Now, using what you've just learned from question 1b and d, I want you to have a go. I'm going to give you, let's make it, how long should it take? I reckon maximum 4 minutes. Let's pause the video.
So it says between x to the 4 on the sheet.
Yeah, that's missing.
Oh, okay.
Yeah. All right, here we go. So this problem, it's a little detail here to note. So we factorize it. So x to the power of 4 plus ax cubed plus 2x squared is equal to 0. Note that they all have an x. So I would have taken out x squared as a common factor. That gives me x squared plus ax plus 2 equals 0. Then here you got to think a bit before you actually attempt the problem. They said they only want one solution. Now if I solve that, this is a turning point. That's one solution at x equals 0. So you already got a solution there already. That means this quadratic factor, whatever a is, I need it to not touch the x-axis. If you visualize this problem, it's a quartic graph. So it could look something like this. But I need the turning point to be at 0. So you can expect it to be like this. What I need is, if it only has one solution, meaning that it only touches the x-axis once, that means the second part must not touch at all. So the only way for that to occur is that the discriminant for the quadratic must be less than 0. Otherwise, you have a problem. If you let that equal to 0, then that's a problem. We said we want only one solution. So discriminants, again, discriminant is b squared minus 4ac. Discriminant is a squared minus 4 times 1 times 2. And you get a squared minus 8. That's your discriminant. Draw out the graph. Here's the discriminant by a. A squared minus 8 essentially just looks something like this. Turning point down here is 0, negative 8. And then here are your x-intercepts or a-intercepts. If you solve for it, it should be root 8 on both sides, so negative root 8 and positive root 8, which is really what? Negative 2 root 2 and 2 root 2. So now let's answer the question. We want that quadratic factor to not touch the x-axis at all, meaning no solutions. The only way that occurs is the discriminant is less than 0. So for it to be less than 0, what are my values of a to make sure that I get one solution for this expression or function, quadratic function, is a needs to be between negative 2 root 2 and 2 root 2. Can't equal to it because then I'll have another solution that makes it now 2 solutions. But I only wanted this entire thing to have only one. Okay? All good with that one? So a nice little trick there. So just read the question properly. Only one solution. All right, next one. Turn over to the next page. This one's an interesting one. At first it looks scary, but it shouldn't be too hard. I'm going to give you 3 minutes this time to have a go with this one. Recording. Here we go. Question 4D. Find the coordinates of the point of intersection. It looks scary at the start, but note that when you have a linear, you can rearrange them, especially this one, to make y the subject or x the subject. It's up to you. So here I would have got what? X squared plus y squared is equal to 97. And I can rearrange this side to be y equals to 13 minus x. So if I put it in, that could be x squared plus 13 minus x squared is equal to 97. Expand the brackets. 169 minus 26x plus x squared equals 97. Simplify them. That gives me now what? 2x squared minus 26x. And if you take the 97 across, what's that? 169 minus 97, extra 3, so 72. Take out 2 as a common factor. Just divide all of them by 2. So you get x squared minus 13x plus 36. And that simplifies nicely into 9 and 4. So therefore, x could equal to 9 or 4. But remember the question was asking coordinates of the point of intersection. So you should find out the y values as well. Y equals 13 minus x. So 13 minus 9 gives me 4. And 13 minus 4 gives me 9. So therefore your 2 coordinates is 9, 4 and 4, 9. Hands up if you got that one right.
Put your hand down. Put your freaking hand down.
Oh my god, that was like 3 students. That's crazy.
I got everything right except for I just messed up the addition, like the easiest part. Like I went minus 97 from that side. I actually made it 28. I don't know why.
I see. All right, team. Last question. Now this one is a nice one. Question 20. There's a couple of things to think about. So let's see, 10:01. Yeah. Oh no, we only got 15. It's a bit tight on time. Maybe we'll just do it together. All right, here we go. Solve the simultaneous equations. You tell me, what are you going to do for the first step? To solve for simultaneous equations, what would you do? Let's go with Samuel. What's your first step? What would you do?
First you have to cancel out one of the values.
Very good. So you got y equals mx, and you got y equals 1 on x. One of the best ways to cancel out one of the variables is simultaneous means you're assuming they intersect, so hence the y values are the same and the x values are the same, so you can equate them. You can say these two are equivalent. So the first step that you should all be doing is then saying mx must equal to 1 on x plus 5. Next step, what are we going to do now? Albert, how am I going to write x in terms of m? Because that's what they want. Solve the simultaneous equations for x in terms of m. So I need to somehow rearrange it to solve for x. Yep. Very good. Multiply them all by x. The only one thing to be careful of is to make sure to multiply the 5 by x as well. And so you should get mx squared is equal to 1 plus 5x. Now we can move them all across into one side to make it a quadratic. So mx squared minus 5x minus 1 is equal to 0. So what do we do now? What do we do now? We're trying to solve for x in terms of m. Alex, what do you do now? Yeah, solve for x. Just like before, question 1D or something like that. We're trying to solve for x. So here, use your quadratic formula. X will then equal to negative of negative 5 plus minus square root 25 minus, what's that, 4 times negative 1, so positive 4 for m over 2m. So that becomes positive 5 there. All right, so I've got my x in terms of m. Again, if they ask for conditions, you just got to make sure that 25 plus 4m is greater than or equal to 0, depending on what the conditions are. All right, next one, B. Find the value of m such that the graphs of y equals mx is a tangent to the graph of y equals 1 on x plus 5 and give the coordinates of the intersection point. Keyword was tangent. What does tangent imply, Neil? It contacts at one point. So the simultaneous equation, when it touches with it, it should only touch once. Now you've already done the simultaneous equation. Here's your x coordinate of the intersection. So if that's your x coordinate of the intersection and you only want one solution, so you want x to actually end up being just one, what must happen? Discriminant needs to equal 0. And in this case, remember, discriminant is under your root. You already figured out the discriminant. It's 25 plus 4m. So what do you need? You need the discriminant equal to 0. But since discriminant is 25 minus plus 4m, you just needed that to equal to 0. Now, 25 plus 4m to equal to 0 to make sure that you get one solution. Well, that means m Actually, are they asking for m? Oh, they did. Find the value of m. Yeah, so m must then equal to negative 25 on 4. Now, I've answered the first part of the question. It said find the value of m. But then the next part is, and give the coordinates of the intersection point. How do I do that? I need to know where they intersect. What do we do now? Sub where?
You sub n into y equal to mx.
And then what do you do if you did that? So y equals negative 25 on 4x. Say that again. Oh, you sub it into the other one and you do simultaneous equation. Now you can. Now notice the space I gave you. I gave it very little for a reason. That was the solution. Remember, you already done the simultaneous equations. This is your x coordinate of the intersection. So all you have to do was sub it back in here. But the reality is that you said you want one solution. That's going to be 0, regardless. That's why you solve for m. If you sub m back in here, it should cancel out to be 0. So really, the x coordinate should just be 5 plus or minus root of 0 over 2 m, so 2 times negative 25 on 4. Just logically. So think about the problem. That's why I said question 20 is nice, because if you think about it, it's like we've done the work in part A. Part B is meant to be quick. Yeah? So here we can see that that's what? 5 over negative 25 on 2. Out of curiosity, because they do this in the exams, does anyone know how to do that? Because a lot of students leave their answers there. With my 9 Accelerate, they've left their answers like this. How do you do it?
I've popped the 2 at the very bottom up to the very top, because 5 divided by negative 25 on 2 is the same as 5 times 2 at 25.
Very good. If this fraction in the exam scares you, you can write it out like what Pat said. 5 divide negative 25 on 2. This you've practiced. Yeah, so 5 divide negative 25 on 2 is exactly the same as 5 times the reciprocal. And we can see that that becomes negative 2 on 5. Okay, so I know this is negative 2 on 5. Then how do I find y? Yes, now you sub that back in, because the y coordinates are the same. This is easier to work out. X you know, which is negative 2 on 5. And m you do know, which is negative 25 on 4. Times them together, the 5s cancel out, so that's 5, 1, 1 on 2. So it's positive 5 on 2. There you go. Okay, so just think about the problem. And the final question, for which values of m do the graphs not meet? What do you have to do now? Let's go with Mia. What do you think? Last question. For which values of m do the graphs not meet? Yeah. Discriminant is less than 0. And again, this is a 25 plus 4m graph. It's a linear. So linear is nice and easy. That's a y-intercept of 25. X-intercept of what? Negative 25 on 4. So here's your line. That's your discriminant graph versus m. So you want it to be less than 0, so it must be this region. So what must m be? Okay. That's it. So pretty straightforward, pretty nice. But what was nice was A and B. How it almost feels like you can make it more complicated. You go back to what you're used to, or if you think about the problem, you did all the work in part A. And so part B was quite interesting in that sense. Anyways, I'll stop the video there. That finishes us at 10:09 with the quiz. So you didn't have time to do your thing there, but rest assured that tomorrow's session, we're on chapter 5. It is much easier. Exponentials, logs. We'll just revise your indices and solving. Okay?